Hello, my name is Janusz and I will talk about benchmark lidar odometry ROS wrapper to HDMapping. This work was published in RAL. I will show you after a second, so let's make a deep dive into this link. Following hint, our favorite banker data set. So we have a lidar odometry wrapper. So first step is already done because we prepared data, and now let's jump into step second, prepare Docker. Hopefully everything works well. So just make a directory, go here, clone our repository, then go there, then check out to our favorite branch. Finally, for this step, we build the Docker. Step 3, convert data. So we run this one. Then we go to the data, and then we convert. Oh, it already exists, so in my computer it exists. So we close the terminal, then we have step 4. We open terminal, we go, then we change some files, accesses, then we go to the data, and finally we launch algorithm and observe. During the calculations I will try to give you some comments about where to find information, and yeah. So shortly speaking, this is algorithm working on this side, and I will, so to find information about this you can always back to our main page, HDMapping page, and then find your interesting algorithm. This is this one, and on the main branch we always put the link to the paper, and you can see this fantastic algorithm here. You have some demos, and what is very interesting, it is our data set. This data set from my colleague Michał, I will show you. If you type Livox 160 and if you have this movie, this one, mapping with Livox, it is from Michał. He is my colleague. And he made this data set, and I am very happy that this data set is used already in RAL. I think we should publish this data set in Zenodo. I will encourage my colleague to do that. So you can see that you have already, it has already 12K views, so let's hope. Let's back to this algorithm. So you have some usage, you have some data, and it is published in RAL. So let's hope it will give fantastic results. It is still calculating, and it looks very promising. So let's find maybe paper. Do we have some paper here? I don't know. Only videos, and there is no paper link. Run examples. Okay, so let's wait a little for the calculations. I will now show you data set on the left side to give you impression what we are calculating. So our data set is this one. You can find information. So you can see data set as a underground bunker. It is done by our colleagues, Charles and other colleagues from Royal Military Academy, thanks, and Ghent University. Thanks to them, we have this fantastic data set that was collected with this toy not toy, this is professional equipment. I hope it will be commercial available soon. I would like to have something like this in my lab also. And what you have 3D lidar, you have active stereo camera, passive stereo camera, time of flight camera, and multiple inertial measurement units. And shortly speaking, short about this data set. So it is challenging since it is because there are plenty of narrow passages, narrow corridors, turns, and different lighting conditions. I can see this challenge from plenty of algorithms that we have already, and I think we should focus as a scientific community for such situations because it is still unsolved. I believe this is a great opportunity to focus on that. So I hope in this year we can find some solution how to cope with such demanding scenarios. Okay, so I think we are approaching end of our experiment. It is quite new. It is quite new algorithm. So if you go to our website HDMapping, we organized algorithms that always you have date, where it was published, and movie about it. So you can you don't have to run all algorithms. It is enough that you watch movie, so you will have some insight before you choose a proper algorithm for your let's say scenario or application. So I hope this set of movies will help you to find a relevant solution for you. Okay, we are approaching end. I think we are. I don't think so. This trajectory is correct. We have some issue, but don't worry. More important is to show you how it works, rather than having a good result, because more important is that you have quick overview of the system. Okay, we are approaching end, and so we can expect data soon. So we are, where are we? So what we should do now, let's go back to our instruction. And in our instruction, it is written that we can open and visualize final data. So yeah, so let's watch it. Shortly speaking, data is here, HDMapping lidar odometry ROS, and once we open our software, HDMapping from GitHub, step 2, multi-view TLS registration step 2, you can load this data. So you have this trajectory that we can use in our benchmark. If you decrease number of removed points, you can see some result, and then finally you can save mark scans in global scan. So we can save it in LAS. And obviously you can save all marked trajectories as XYZ and quaternion. So it is like a TUM format, TUM. So we have trajectory all CSV. Oh, I make mistake, I hope nothing wrong happened. I have to fix it. Okay, let's open Cloud Compare. And let's drag and drop our trajectory X, Y, Z. And let's drop our point cloud. So you have point cloud and trajectory for further qualitative and quantitative analysis. I was very happy to serve you in this, so let's hope we will have more information soon. Thank you very much for listening once again, and see you soon.